Alright guys and gals, it is I, Coach Gu, back again with another fun-filled, action-packed flip geometry classroom video. This one, we'll be learning all about angle relationships. Angle relationships in the circle. So, let's start with the first section. It's talking about where's the angle vertex, interior intersections. So, if you have angles on the inside of your circle, just randomly, looking like this picture right here, what are the rules? Let's figure them out. So read the definition. If two secants or chords intersect inside a circle, then the measure of the angle formed is equal to half the sum of the measures of the intercepted arcs. What does that mean? Take a look at the formulas on the right side. Look at the picture. Look at the diagrammerino. Let's say you want to find the measure of angle 1. So I'm going to do it right here. Angle 1. That's not a good color for that. Angle 1 right here. Well, they're telling you the measure of angle 1 equals 1/2 the measure of arc AB plus the measure of arc CD. All right? And if you wanted to find the measure of angle 2, they're telling you that on this picture, it would be half of the measure of arc AC plus the measure of arc BD. All right? So, one thing that you should notice here, let me show you on my personally drawn diagram right here. Whoa! All the angles, all the measures of the arcs, so like this, plus this, plus this, plus this, they all have to add up to 360, okay? All need to add up to 360. Now, what exactly were those formulas? Oh wait, that's not where the 2 is. What exactly did those formulas say? In case you didn't get it, you want a more visual, just kind of from the rough. It's like this. If I wanted to find the measure of angle 1, I like to imagine that there's a little piece of pie. See this piece of pie? Whoa, that's a measure of angle 1. Okay, but where's the piece of pizza right across from that one? That's over here, right? So if I wanted to find 1, I'm going to draw those 2 pieces of pizza, and there's going to be numbers. There's going to be measures of angle. So let's say this one was like 120 over here, and this was 60 over here. Well, I would take those 2 measures, it's 120 degrees and 60 degrees. I'm going to take those 2 and put it in my formula. So the measure of angle 1 equals 1/2 of one piece of pizza, 120, plus the other, that's not a 60, and it would just be this, so that'd be equals 1/2 times 180, that's 90, done, there it is. And then just like that, if I wanted to find the measure of angle 2, let's say this is 90 up here, and this is 90 down here too, okay? Then, let's draw my pieces of pizza. I got this one right here, okay, and then where's the piece of pizza right across from it? That's this one. It's always 2 pieces of pizza. No one wants to eat just 1 piece of pizza. You gotta eat 2 pieces of pizza. Alright, so anyways, if I want to find the measure of angle 2, formula is measure of angle 2 is you're gonna take equals 1/2 the sum of those 2 slices, 90 plus 90. That's gonna be 1/2 of 180 equals 90. Wow, it's also 90 degrees. So 2 is 90 degrees. 1 is 90 degrees. There it is, just like that. So let's look at that in an example. My first example right here, AED. How would I do that? So I'm going to find the measure of angle AED. First, let's determine where that is. So AED, so from A to E to D. That's this angle right here. Let's draw our little slicerinos. There's one piece of pizza. Where's my other one? Right across from it, it's going to be this one. All right? So, what's my formula? I'm going to take, let's just label this as measure of angle X, okay? Measure of angle X, I'm going to take 1/2, and then I'm going to add the 2 numbers, the 2 measures of the arcs that I found. 45 plus 109. What's 45 plus 109? That's going to be 154. What's 1/2 times 154? That is 72. Oh, wow, I'm so dumb. 77. And so my answer is 77 degrees. just like that. So you guys try the one on the right side. All right, next let's take a look at what if the angle vertex is on the circle. What if the angle, that's not the right thing. What if the angle vertex is on the circle? So let's take a look at the rule here. If a secant or chord and a tangent intersect at the point of tangency, or on the circle, then the measure of each angle formed is equal to half the measure of its intercepted arc. So if we take a look at the rules here, if you're looking for the measure of angle 1, we can see that measure of angle 1 takes up this whole thing right here. So you take 1/2 of that arc ABC, and that would be the measure of angle 1. If I wanted to find the measure of angle 2 right here, then I would take 1/2 of the measure of the intercepted arc, which is AC right here. So that's how you would do these ones. Now let me show you just a visual to make sure you understand this. So this is exactly what you have on your paper, but we're always talking about a tangent and a secant or a chord, okay? So the secant or a chord is just like that knife that just straight up cut this pizza into 2 pieces, but they're usually just really uneven pieces. So, I mean, maybe they're not, but just in all these examples, they are. So we just cut this pizza into 2 pieces, and measure of angle 1, you see this? That's this piece of pizza. Huge right there. And then the measure of angle 2 would be this smaller piece of pizza. All right, so these are the related angles and the measure of the angled arc. So for example, if the measure of arc ABC was 260 degrees and the measure of angle AC was 100 degrees, how would I find the measure of angle 1? I would just take this 260 divided by 2, and that would give me the measure of angle 1, which would be 130. So 1 would be 130. How would I find the measure of angle 2? I would take the 100, divide that by 2. That gives me 50 degrees, and the measure of angle 2 would be 50 degrees. Let's say in this situation that they told me, look at this, I'm going to erase the 2. They told me that this angle right here was 50 degrees. How would I find the measure of arc AC? That would be from A to C. Well, remember, the angle right there is always half of the measure of the arc. So the measure of arc AC would be 2 times the 50 degrees. So the measure of AC would be 100. And then just like that, if I wanted to find, let's erase this 1. Oh, whoops. Let's erase this 1, and let's say they just told you straight out that over here is 130 degrees. How would I find the measure of arc ABC? Well, the measure of arc ABC is twice, it's 2 times as big as the measure of the angle right there, so it's 130 times 2, which is 260. So the measure of arc ABC would be 260 degrees. So it works both ways, okay? In our first example, measure of angle DEG. They want us to find DEG. So first, let's take a look at where that is. D to E to G. That's this angle right here. Okay, now that I know that's the angle right there, I'm imagining that my pizza's been cut into 2 extremely unfair shapes. So there's my angle right there, and this part of the pizza is right, bam. I'm gonna see all that, heck yeah. That's 308 degrees. You can see it's labeled right here. So if I wanted to find the measure of that angle, DEG, I'm going to take 1/2 times 308, which is the same thing as 308 divided by 2. And my answer would be 154 degrees. That's the measure of angle, DEG. All right, so now you try the one on the right side. This is a working backwards one, or working the opposite direction. And now for the last section, what if the angle vertex is on the exterior or outside of the circle? So let's look at the rule here. If a secant and or tangent intersect outside a circle, then the measure of the angle formed is equal to half the difference of the intercepted arc. So if it helps, you can remember that the average, it is the average arc difference. There we go. All right, so let's say there's two secants. Now look, we have two secants here because, let me use this color because it's funny. Two secants here because they intersect at 2 points, you see? And AE intersects at 2 points. So that's a secant. And then the rule here is if I wanted to find the measure of angle A, which is this measure right here, I'm going to take the difference of half. So I'm going to take 1/2 times the measure of angle DE. It's right here. Minus the measure of angle BC right there. All right. And if you want a random, if you want an imagine, scenario, I like to imagine that there is a big giant Pac-Man guy. Yeah. See that? And I'm only looking at the part that he's eating. So anything inside my Pac-Man, I'm not paying attention to that. So look, what if I were to just erase this, like goodbye. You see? My Pac-Man's eating just that thing right there. That's all I can see. So just that. All right? Looking at the next one. This one is a tangent and a secant. Look at this. AB is a tangent because it intersects at only 1 point right there. And then AD is a secant because it intersects at 2 points. That's C and D. So we can do the same thing. It's measure of angle A equals 1/2 of the measure of angle BD, or the measure of arc BD, which is this right here. Oh gosh. Minus the measure of arc BC. And if you need a visual to help you remember which arcs you're using, once again, you can do a giant Pac-Man. Oh yeah. And then just erase everything that's inside the Pac-Man guy and look at just what he's eating. There it is. These two. You notice that it's always at the points that the arcs separate. In the case of two tangents, look at this. AB is a tangent because it's intersecting at 1 point. And AC is a tangent because it's also intersecting at 1 point. Make sure you know where those points of tangency are. So look, I'm going to highlight them for you. Point B and point C. That's going to let you know, because you can see in this case, if I were to draw a Pac-Man guy, I'm eating the whole circle, right? I'm eating the whole pizza. But the points of tangency let you know where the split off is. So one of my split offs, look at this. It's going to be 1/2 if I wanted to find the measure of angle A right here. It's going to be 1/2 of BDC, but look, B to D to C, the points of tangency tell me where to start and where to stop. That's BDC. And then minus arc BC. You see I'm going from B to C, stopping. Starting and stopping at the points of tangency. So let's take a look at one of these in an example. The measure of angle KLM. Where is KLM? That is going to be right, let's see, K to L to M. So that's going to be right there. I want this. All right, so now look, I'm going to use my super secret strategy of drawing Pac-Man. So look, I've got one right here. And one, so I've got two secants here. And then I want to look at the arcs that I'm trying to use. So, I'm going to erase what I don't need by drawing a giant Pac-Man. And anything inside the Pac-Man's head gets erased. So goodbye, this is gone now. And this one over here is gone. So it's only what's inside his mouth. There we go. So the formula to find this measure of angle KLM right there is going to be 1/2 times, take the big arc, which is over here now, you can see, 140, minus, where's the other arc? It's this small leftover section down here, which is 66. And so 140 minus 66 is 74. And just multiply that by 1/2. And that gives you 37. And your answer is in degrees because we're looking for a measure of an angle. So the answer is 37 degrees. So now you guys try the next one. And that's going to end these notes. So until next time, peace.